You are each going to be a molecule. Molecules are always in motion. Since we did an investigation last week with 2 cups of water, hot water and cold water, you are each going to be an H2O molecule. Congratulations, you are made of 3 atoms, 2 hydrogen and 1 oxygen. You are a molecule. We're going to start off just moving around at room temperature. Room temperature will just be walking around at a normal pace. So go ahead and start walking around, mixing up, because molecules are always flowing and moving and mixing.
Scared.
Okay, now we're going to cool down and become ice water. Are molecules moving fast or slow when it's cold? Slow. So, move slower. Are we going to be mixing up as much? Okay, so we're all moving slower. If you bump into someone, it's more gentle than before. Just small little bumps. Okay, now we're going to represent the warm cup. Start moving faster than a normal walk. This is hot water. Molecules move fast. Okay, don't push them like that. Okay, stop. Stop. Okay. Can you get colder than frozen water?
Yes.
Water freezes at 32 degrees Celsius, or 32 degrees Fahrenheit, or 0 degrees Celsius, which means it kind of gets locked in place. And the atoms can't move, which is why ice is solid. But molecules in solids are still moving. They're not moving around and mixing, but they are like vibrating and kind of just like moving side to side a little bit, but staying in place. Can we still make them slower, even if it's even if it's frozen?
Yeah.
Yeah, you can get stuff that's like negative 10 degrees Fahrenheit, negative 20, negative 30. Dry ice is like negative 120. Liquid nitrogen is like negative 200 degrees. You can keep getting cooler. And as you get cooler, you move slower and slower and slower. So, I want us to move around again. I'm going to get you slower and slower and slower as we get colder until we come to a complete stop, okay? So we're going to start at room temperature, walk at a normal speed. Okay.
Photobomb.
We're cooling down, start moving slower. Okay. Slower again. Okay, go slow so that you're only taking 1 step every like 5 seconds. Okay, now we're very cold. Okay, even colder. And stand completely still. We are at the point where all motion has stopped. Can we get slower than no movement? If temperature measures movement and our movement is stopped, can we get any colder than we are right now?
No, not as a water molecule.
It is not possible to be slower than what you are right now. Answer yourself. Okay. If we can't get any colder, that means there's a limit to how cold you can get. Does anyone know what the term for the coldest possible temperature is?
Absolutely.
Yes.
Like the temperature of Antarctica, like negative 40 degrees.
You can get a lot colder than Antarctica.
Oh,
Okay, yep, I heard it from 2 people. There's a term, absolute zero, where all motion stops. It is impossible to move slower or get colder than absolute zero because all molecules are absolutely still. What temperature does absolute zero occur at? 10 tenths.
273.15.
Okay, my shirt says negative 273.15 degrees Celsius. This is the absolute coldest it is possible to be, which is why underneath that temperature it says totally chilled, because you can't cool anything down any more than that. That is absolute zero. We are going to go back into our rooms. We're going to read an article about absolute zero, and then we're going to watch a video about why it's impossible to reach absolute zero.